So what you guys are looking at right now is the MVT example that period 1 did not get to yesterday. Period 6, I at least was able to show it on the screen. I think I might have actually solved most of it with them. But anyway, you guys, I posted it in your Google Classroom that it was there, and I let you guys know that I was going to make it available to you if you were trying to do those ones in your homework. I think it was towards the end of homework, though, right? The MVT showed up? Okay. So anyway, I had an example for you guys to check out so you could follow it, but we'll talk through if you guys have any questions as you're writing it down if you didn't already. But what I just passed out to everybody was the practice test bonus, which of course is also in Google Classroom. You can print it out from there if you're absent. But that is due next, it showed up this morning, Wednesday. Because next Wednesday is the day of the main part of your test. You guys can go ahead and just kind of recalibrate as far as with the deadlines over here on the right. Today, remember our goal, section 4.4 was due this morning. Today, oh, my black marker is gone. Today, our goal is to go ahead and go over homework questions on, I think in this class, we already did 4.3. In period 6, we'll probably do some in 4.3. But then also homework questions on 4.4. But after we do our homework questions on 4.4, we're going to get back into our motion packet. So we're returning. It's the return of the motion packet. So if you guys don't already have your motion packet out, which you probably don't, I haven't said anything about it, go ahead and go find that motion packet for me. The one that we were working on in section 4.1b with speed increasing and decreasing. You guys did example 1, example 2. No, you did example 2, example 3. We did example 1, and then you did worksheet number 3 about speeding up and slowing down. We do have one last remaining forever card to get into our notes and to use in our motion packet. So after we grade our homework, have our pens out and ready with your homework from last night / this morning, whenever you were doing it. And then your motion packet is where we will be going to next for the return of the motion packet. And that motion long answer part is on Monday. And so I'll give you a couple of hints before the day is done as far as what that's going to look like. But my best hint for right now is it's like section 4.1b with like an A, B, C, D, something. But that's all you're seeing on Monday as far as the test is just that motion long answer so that for the test on Wednesday, you can rest assured that motion, like position, velocity, etc., won't really be on it. It'll be everything else. You can focus your attention. Does that kind of make sense? Kind of, sort of. Okay. Let's go ahead and pause the recorder for a second. Let's pray for our moon. Before we go over that MVT example, and if you guys are stuck on the MVT in homework, which is totally fine, then I'll use that example to go ahead and teach, okay? So that example I had on the screen, once again, it's in Google Classroom. If you need to, you can open it up in Google Classroom. But let me go ahead and get the evens up here on the board. Oh, I think these are the only evens. You can see them all in one fell swoop. Let me zoom in a little bit. I want you guys in your groups to check in with each other. How did homework go? How did the odds go? You're checking the evens, but first of all, check in. How is everybody doing? And if someone is stuck, if someone is confused, if there's like a whole topic, they're like, I had no clue. Can we discuss it for a little bit and see if we can narrow down questions? Ready, set, check in. Nehemiah, you can go ahead and join the group right next to you. All right, sounds good. Meanwhile, I'm passing around two things. I'm putting in the order for some shipping sweatshirts on Monday afternoon. By the end of the day, I'm also passing around a jeans segment. So make sure if you've written down an order, that's the size that you want and a type that you want, because once the invoice is in, it is what it is. And it is solid. And make sure if you want one that you can put in the order Monday after.
Right. But you weren't getting one for the. No, she just did. Because I said we're going to put it in the quarters there, so now I can use it. We'll just get a quarter of the cow. Just don't get one for this beat. Easier one. Actually, that'd be kind of fun. We're gonna sell it. This is nobody likes it. Ask them. Oh, this is what we want. And there's one. Oh, you split them up? Some guy. I will have to get you some more. You can split them up. Thank you for the share. I know, I really did. Cool.
All right, guys, have we graded all of our evens? I mean, there's only 3 of them. But we've got the answers down of 19 over 2, of 6.4178, and of C2. Okay, I'm available. In odds or evens, is there anything that you still do not know why the answer is what it is or how the answer is what it is? Okay.
27.
27. Okay. Anything else?
75.
75. Good. Anything else? 115. Okay. Let me go ahead and pull up my webcam so that we can look at these so you guys can be peeking and seeing if there's anything else that you want to see. Okay, so I think the first one that I had was yours, Kyle, which was number 37. 27, thank you. I couldn't remember which 7 it was. So number 27 was... Remember that my book does give the answer, so the answer that we're trying to get is that 2 plus pi. That is not part of the problem. Sorry, in my head that looks real weird, but it's nice to have the answer. So we can go ahead and get that number 27. Adam, yours is next, which was number 75, yeah?
Yeah.
Number 75 is over on this page. Here we go. Which had to do with analysis of a function given a graph. And hopefully you guys realize that graph below, or else, man, that would have been a sad problem. If you guys notice, FTC Part 2. FTC Part 2. Remember, if you're bored, you can always be getting in Google Classroom, writing down the test review and working on that. You could also be filling in your forever cards, since we now have cards 29 through 37. All we're missing is the motion one from today. But just letting you know, you don't have to totally be feeling like your time is being wasted if this is not helpful to you. Going. Here we go. Okay, let's get rid of that graph because we don't need him. And then, Vico, you wanted number 115, yeah? Okay, number 115 was a multiple choice, and the wording was key. The wording was key. So it doesn't say average rate. It literally says, which not all problems do, but this one does. It literally says find the average value. Oops, well, Adam will get 115 done right now. Okay, so let's start back with number 27. Number 27 gave us a function, and I believe all we needed to do was take the integral. Sure? So integral, fundamental theorem of calculus. We have to find the antiderivative and evaluate that from 0 to pi, I believe. So the antiderivative of 1, Kyle, should have been x. The antiderivative of sine would have been a negative. Good, good, good. Okay, now we have to do f of b minus f of a. Who do I plug in first?
B.
Which one's b?
Pi.
Top guy, right? Top guy falls in and the bottom guy comes in after. So top guy would be pi minus cosine pi. My question, I guess, is, do you know your unit circle? Because this would have been pi minus cosine of pi. A couple different ways of thinking about it real quick. One of these days, maybe one of them will stick with those of you that aren't so great at the unit circle. It's going to be minus a negative 1. The other way of thinking about it is, if you do this cheater chart, 1, 2, 3, negative 2, 1. There you go. At 0, it's positive 1, which is over here in the unit circle, right? But at pi, instead of being a positive 1, it's going to be a negative 1. The sign has to flip. That's a little bit harder with the cheater chart on the quadrants. So some of you on the quadrants might just be sticking with those x's and y's and remembering that the cosine is always the x. Either way, pi minus negative 1 minus, don't forget your, well, 0 is 0, so I guess it doesn't make a huge difference. But you need to make sure that you are distributing this negative in other cases. But I have negative 1 because it's a negative and cosine of 0 is 1. And so I have a minus negative 1, which is a plus 1, a minus negative 1, which is a plus 1. Hence, I have pi plus 2, and they just wrote it 2 plus pi. For number 75, that one's a bit more exciting in the sense of there's an A and a B and a C and a D. Ooh, I just heard fun with a math problem. What? Okay, let's zoom in. I heard it. Did you hear the fun word? I heard the fun word. All right. We have what is called an accumulator function, and if you guys are the highlighting AP problems type, this is one to highlight. They love giving you something that looks like this. They love giving you what's known as an accumulator function. They love giving you an accumulator function. Now, kiddos, check it. Isn't this g of x? So what is 0 and 2 and 4 and 6 and 8? What variables are those? X's. So if I am trying to find, for instance, letter A, and it says g of 0, what it means is plug it in which spot? The x spot, right? So g of 0 is 0 to, well, 0. Oh, that's super nice. Because I know any definite integral from A to A is equal to? But when I go to do g of 2, well, all of a sudden, now I need to move from 0 to 2. These are called accumulator functions because as you plug in increasing values of x, they accumulate more and more and more. What's a definite integral given a graph? Area. So what would be the area from 0 to, wait a minute, it's impossible. I can't do that. It's curved. Which is why it uses the word estimate. Can you guys tell me how much area is in a little box?
Yeah, 1.
1, because it's a 1 by 1. It's a little square, right? So how many of those do I have? 1, 2, 3, 4, 5, 6. I don't know, maybe 6.5-ish. 6.75-ish. 6 and maybe 7-ish. I'm gonna do 6.8. Did you say 7? I'll go 6.8. That's more exciting. Okay. If I keep going to PS, the AP would never ask you this and say estimate if it wasn't a Riemann sum. They would either give you a geometric shape that you could find exactly, or they would actually somehow in the given problem let you know what the curved areas are. G of 4 would be from 0 to 4. I just need to keep on going a little farther, so check it. If I go to 4, I still have, okay, should we use 7 just to make it nice? 7. Okay, we have 7 from 0 to 2. Then am I kind of just adding a triangle to keep going? So my triangle would have a base of 2 and a height of 2. Wouldn't that just be 2 more? So can't I say 7 plus 2 more would be 9? And that would get me like all of this area. And then it says keep on going to G of 6. Well, guys, what happens between 4 and 6? It goes below, which means goes negative, and we haven't done a lot of those. But going negative, let's see, 5 and 6, it goes negative, kind of still a triangle, right? With a base of 2 and a height of 1, which would be 1/2 base times height. I'm just going to need to subtract 1. I just need to subtract 1 for this extra area that's now negative. And then for me to go to 8, I can just keep on accumulating and go from 6 to 8. And as I go from 6 to 8, I think I have some more negative area, yeah? Ooh, that's a trapezoid. That's kind of gross. I don't know if I like that. That's a 1, that's a 2, that's a 3-ish?
Yeah.
So then I'm going to subtract 3 and I'm going to say it's 5. Ah. I'm just using my boxes to approximate now because I got lazy. I guess we could have done a height 1 plus a height 2, which would have been 1 plus 2 is 3, and 3 divided by, no, 3 times 2 would be 6, and 6 divided by 2. Height 1 plus height 2 times base times 1. Yep, that'd be 3. Take away 3. Okay, but that was all for letter A. Letter A, we had to think areas, and we had to think which areas, and we had to estimate as best we can. What does letter B ask for? Largest open interval. So largest beginning to ending of those x's. You just move from 0 to 0, 0 to 2, 0 to 4, 0 to 6, 0 to 8. On which G is increasing. And then decreasing. How do I think about G increasing and decreasing? How do I think about anybody increasing or decreasing? Who do I look at when the increasing, decreasing word comes in? Consider the signs of who or what? Not G. Increasing, decreasing. Increasing, decreasing test, I look at box prime. Right? CalcAB, I look at box double prime. So if I'm trying to consider box prime or G prime, then don't I have to take the derivative of that? Oh, wait a minute. How do I take a derivative of an integral from A to X or A to U? F, T, T, part 2. You guys have your notes close? How do I get the derivative of a definite integral? I just do it. So to find G prime, all I need to do is take a derivative, write it out if your brain needs it, from 0 to x of my f of t dt. Isn't that just going to be plug it in, times hidden prime? So f of x times 1. Oh. G prime's just f. Who's f? The graph. So if I'm trying to figure out where G prime is positive or G prime is negative, I'm trying to figure out when F is positive or when F is negative. So kiddos, when F is positive, that indicates that G prime is positive, hence G is increasing. What's the longest time that F is positive? 0 to 4. Why? Because positive just means above values. Positive just means above values. Doesn't matter that he's constant or decreasing. I don't care about F increasing, decreasing. I care about F being positive or negative. So when is F above? From 0 to 4. When is F below? From 4 to 8. So I have when he's above, then G is increasing. And when he's below, he meaning F, and I have to define that or else they don't know that I have complete understanding. But when F is negative, then G prime is negative, which means G is decreasing. And that's on that other interval from 4 to 8.
Would you ever use like closed brackets for the 0 or the 8?
It's at the largest open interval, so I just kept it open. But technically, Adam, you're exactly right. If we were to do this precisely, and if we were not just answering what they told us, that should have been closed because at 0, it's above. And this should have been closed because at 8, it's below. 4 is a 0, which is neither. It really says open interval. It's a weird, probably book variation on it. Letting you know, just keep it open, don't stress. But technically, in this case, you're right. That should have been closed and that should have been closed. For letter C, whoa, extrema of G. I don't have G. I have G's derivative. Wait a minute. Have we ever had to work with a derivative graph to find relative extrema?
Yes.
Yes. It was a long answer on the final. It was a long answer on the test before the final. Wait a minute. What did we just do? What is G doing? Don't look there. What is G doing from 0 to 4?
Increasing.
What is G doing after?
Decreasing.
What's in between?
Sign change.
A 0.
A 0. Oh, so it goes up, it flattens, and it goes down. Who is that guy? Where is that guy? It's 4, but who is he? What is he? What type of extrema is he?
Relative max.
Yep. So then letter C. I have a relative max at x equals 4. Why? If they ask me to justify, I just did it. G changes from increasing to decreasing at that critical number. That's the definition of a relative maximum. Okay, what's letter D? Good. Well, they don't tell me any starting. Oh, they do tell me a starting point. Wait a minute. I know certain values of G, and I know that there's a relative max at 4. Adam says it was your question. Can you keep me honest? I have 0, I have 2, I have 4, I have 6, and I have 8. What did we find in our values for G for those? At 0, G is 0. At 2, G is. At 4, G is. Ooh, I also know that 4 is a critical number, so I know it's going to be going up, strictly increasing, and then it's going down. G at 6.
8.
And G at 5.
Or G at 8.
Oh, sorry, G at 8.
That is
Is 5. Now it's not going down in quite a very nice parabolic fashion. It's a little bit of a weird graph, but at the same time, I'm only allowed to connect these random points like this because I know that G is strictly increasing and then strictly decreasing with a leveling off a 0 in between. So that's the best guess. That's the best sketch that I can do. The best sketch that I can do. Anyway, excellent question. Lots of good stuff in this one. Lots of things aren't very AP-ish. That whole eyeballing of curves wouldn't be this precise. If you're ever eyeballing area with curves, you're going to have multiple choice where there's enough variation that you don't have to like guess between 6.8 and 7. It's going to be like a clear, this one is the closest and the other ones are far off. What else is weird? The AP sketching something like this, they do every now and then have you do a rough sketch, but it wouldn't quite be in this type of accumulator problem. I've never seen them have you sketch an accumulator before. But anyway. It is AP-ish in that they do sometimes have you sketch, they do sometimes have you estimate, just the estimation won't be a long answer, and the sketch won't be with an accumulator. But otherwise, great AP question. Vico, yours was also an AP-ish one, that multiple choice AP practice at the end, but this one was so nice because they were so clear. Once you know your forever cards on exactly what formula to use. Ew, what's bad about it? Where's my unknown? Not there.
Okay.
Oof. That's okay. How do I solve any definite integral? Anti-derive. That was a thing. I just need to solve. So I anti-derive my 1/4 x to the 4th. I plug in my b. I don't know about you guys. I'm going to pull that 1/4 out because then he's going to be in everything anyway. Let's just not worry about him. I'm going to have k to the 4th minus 0 to the 4th equals 12. 0 to the 4th is just 0. K to the 4th over k is 1/4 k cubed. I can multiply 4 to the other side. K cubed is equal to 48. I can cube root both sides, which hopefully you guys know how to cube root. Algebra kids not so much. Cube root of 48.
Is 48 the one there?
Because 48 has a 6 and an 8 go in. 8 has a perfect cube, so k would equal 2 cube root 6. And some of you are like, I just plug it in my calculator. Oh, this is not a calculator problem. Huh.
It's too bad that none of the answer choices are solved. So it would be just 48 to the 1/3.
Yeah, the AP wouldn't have written it like that. So this would let you match it with the AP, but that's alright for everything else. Don't you guys know that it's just the 48 to the 1/3?
Yes.
But that's one of those life lessons in the sense of saving time and being efficient. Take a peek at the answers of the multiple choice before you finish solving, because you might waste time doing something that wasn't even necessary. But that one, in context of wasting time, was a barely wasting time, and that's exactly what the AP would have had, 2 cubed root of 6. But thank you. All right, that was section 4.4. We still need to go back to our motion packet, but did anybody find anything? Oh, I had it ready. Oh, sad day. I even had a good picture of it and everything. Oh, well. That's okay. We use the crappy picture. Test review, chapter 4A, not yet. We need to go find our motion. So hold on. Let's go find our motion. Poor little motion. I left him way back here, just kind of floundering. I want you guys to go find worksheet number 4.
I know, it was so exciting. We all died.
We finished Hamlet too.
Sorry.
If you're a junior and you're not thinking about taking AP Lit, take it. She's coming way easier than regular English.
Motion. Can you guys fill in whatever you know on worksheet number 4? Some of these you should already know from worksheet number 3. The easiest one, right, John? The easiest one of that homework. Fill in what you know, worksheet number 4.
Flash, flash, 100-yard dash. Flash, flash, 100-yard dash. Yes. That was the.
Wait, how's the filling in of the motion packet? It's going well.
I'm talking about cars.
There's so many things like my calc teacher like writing something on the board and then like me like just doodling or like thinking of like
And then you're in the class and you're like,
and it just reminds me of like when you're like, oh, how's that motion back? You're like, oh, how's that example going? And we're just like,
that one. To be sure, is it? That's literally Mariah though. So
we're
like,
we're like barely writing cow. Like,
I was like,
that is so bad for me.
what?
I didn't know not do it.
Okay, now hold on. What you're getting back right now is where you were with antiderivatives. The question is, where will you be by the test? Where will you be by the test? Not where you were, but where you will be.
What is it like?
Does anybody want to do an integration, another integration, makeup one before the test? Okay.
Yeah.
Yeah?
Okay.
Well,
So maybe, I'll take the higher of the 2 scores. I won't let it hurt you. Maybe we'll do another integration, just 3 problems, and see how you guys do.
You didn't make this quiz up, huh? You were here that day.
I did make it up.
Yes. Do you have to know your integration rules?
Yeah.
Let's have a little baby 3-question integration quiz after the forever quiz on Tuesday, because you should know your rules by then. It's going to be the better of the 2 scores. So it's not going to hurt you. But some of you, you're like, it didn't go so well the first time. Well, by the test, are you able to anti-garage? I think so. Look over your questions. Look over the things that you missed. We'll have another little baby 3-question integration quiz that can erase the score. We'll have it under the forever quiz.
What?
All right, what you guys fill in?
Mariah.
Stevie did that.
You can give the answers if you want. I don't care. But what can you fill in?
Velocity.
Yeah, absolute value of velocity. Right?
Yes.
Worksheet number 3. If velocity and acceleration have the same sign, both positive, both negative, speed is increasing. But what's like a colloquial way of saying that? You are speeding up. Colloquially, it's like a silly way, like a basic way, right?
Basic way.
Different.
Yeah. And velocity and acceleration are different in sign. One is positive, one is negative, etc. Then speeding down. Not speeding down. Slowing down. Oh, dear.
I need you to speed down.
I mean, I guess it makes sense. Alright, we're good?
Yeah.
Okay, let's keep going then. What kind of integral do we now know if there are no bounds?
Indefinite.
Indefinite. Nice.
Ooh.
So wait a minute, fill in. I mean, we just want to fill in the blanks, right? That's the point of all this? No. But okay, what can we fill in for this one down here? Okay, because it has bounds, right?
Yeah.
Okay, keep going. It will give you the top one, the indefinite integral. It will give you an expression for, if you integrate velocity, what do you get to?
Position.
Because integration goes backwards with our three main concepts of motion: position, velocity, acceleration. Or we take out the motion, amount, rate of rate.
Nice.
You're welcome. Okay, so for position. At a time t, don't forget that you will have, did anybody not do it on their quiz, a plus
C.
Oh, I didn't do the quiz.
That you'll remember for Tuesday.
I remember it.
Plus C.
Oh, yes.
You didn't even
But
do
I
it.
didn't-
No, I still can't see you. Never mind, forget it. The value of which can be determined if you know a position at a particular time. If you know ready? If you're one of these people, if you know a clue, you can go find a plus C.
Oh, I got it.
Huh? Yeah, you get it, notebook. Okay, number 5.
He was the best
Ow.
drawing crayon, hands down. So just
What?
Yeah, I was impressed.
he was talking about how good he could draw with a crayon.
Maybe he was the one drawing it. Wasn't it always zoomed in on his
Is it
hand? In my
crayon?
head.
I had a
Crayon.
It's
It's
a
crayon.
crayon.
Is it milk or no?
No one says that.
I had the
No.
Really?
house
Like
on
if you
crayon.
go and you're like,
Like
pillow or
pillow.
Like
Like
a
a crayon.
or
You know,
Crayon.
Okay, so
Crayon.
we still have 5 more classes today. And a lunchtime and an after school and needy kids. Okay, so the answer will be, wait a minute, what happens if we do fundamental theorem of calculus and f of b minus f of a? What do you always end with? An equation or a number? It's going to be a number. It's going to be a value. It's going to be an amount, like an actual numeric value. The number, okay, the number. Anyway, represents the change in, wait, but who have we still gotten to? Even though it's a number, who are we still talking about? Position, because we went back with that definite integral. A change in, and if you're a good underlying person, that change in is a very good way of thinking about a definite integral, right? F of b minus f of a. A change in position over the time interval. By the fundamental theorem of calculus, since velocity is position prime, the integral will yield a change in positions. And if you're in physics, or if you might ever take physics, another way of saying this is the final position minus the initial position. That is the definition of box it displacement. However, the answer can be positive or, you guys know. Yeah, I don't even really need to know the concept to fill in that way. Positive or negative, depending on if the particle is landing to the right or left. But what am I going to put down below? Because that's only in a horizontal motion model. What else could it be? Up or down. Good. Of its original starting position. Number 6. Ooh, it has an absolute value. It is also what type of integral? Definite. So the answer will still be a number. But the number represents this time. Do you guys remember? I said it like 5 times yesterday. Total distance travel. But yes, do you understand? Like you're just adding up the distances. Represents the total distance traveled by the particle over the time interval. The answer should always be positive, because we're just talking about like the magnitude or the overall addition of all the distances added up. And now we know how to do these things. So we talked about absolute values and definite intervals. Man, wait a minute. That's 4-1. That's 4-4. And that's 4-4. Okay. You're getting in the end of the chapter.
Oh.
Now hold on. I actually remember how we kind of had to save a card because we were on the track to have 51 cards instead of 50 cards. Anyway, I saved a card right here, and that's why I'm pulling up not that one, but
What if you're wrong?
but now we'll have to save another card, so we have 49 cards. We'll think about it. I was able to squish. So I made 2 cards into one. And instead of calling it like a more motion and a total distance displacement, I just said whatever. It's all motion. Okay, so take a picture of it, write it down. This is our last forever card of chapter 4A. Do you guys see how close we are to 50?
It's 12 away.
Woo.
And we still have 3.5 chapters.
Yeah. Well, no, not 3.5. We'll only get to chapter 6.
Oh, 30 to chapter 8.
No, chapter 6.
Oh,
It's on Google Classroom, right?
Okay, what?
Yeah.
Perfect.
Yeah.
Yeah.
See that?
Okay, I'm going to go ahead and copy and paste this into our notes so we have our more motion.
And
Okay, take one and pass around of your AP bulletin thingamabobbers as you're getting your forever card, your last forever card down. I'm going to go ahead and get rid
Let's
of...
not talk about it. TikTok.
Do you guys want to know about that long answer on the test on Monday?
Yes.
Yeah, I thought so.
Abby, wonder what the long answer on the Monday?
Yeah, oh yeah, God bless.
Yeah, but
Let's get your AP bulletin. Pass it around. Take one. 99 AP bulletins on one. Okay. So we're taking, this is our forever card. I'm freezing the screen in case you're still writing it down. What? No. It is important information for your parents and you about the AP test. Mr. Will, in an email, told you specifically. I have 5 more classes to teach. No, you don't, but you're maybe trying. Mr. Will, in an email, told you guys which pages to read. Okay? Mr. Will, in an email, told you which pages to read. But the whole thing is just supposed to be like an informational, like, hey, you need this. I don't really know why. Okay. I mean, if you've never taken an AP exam before, that would be very helpful, like to look through it, etc. If you have taken an AP before, maybe you're okay. Okay. So,
And then lit.
on Monday, I am giving you the motion part of the test so that we can separate it from the rest. You guys have the motion packet in front of you. Did we do the whole thing?
Yeah.
No. Did we do a bit of it? Yes. We did much of it. If we had extra time, we probably would keep whittling away at it for this chapter, but we'll definitely come back to it and keep working on the motion packet. Part of it is because we haven't learned all the integration that we need to learn. We're going to start off chapter 4B with integration with U's. U's come back. I mean, U's are already in here with the derivative from A to U, but that's different. That's not actually antiderivatives. But anyway, okay. So the test. Let's start. Here's one version of it. That's good. The multiple choicey stuff you're not going to see until next Wednesday. The table with the Riemann sum, not until next Wednesday. The using the properties of definite integrals to solve when you don't really know what the function is, not until next Wednesday. MVT, not until next Wednesday. Solving a differential equation with a clue, not until next Wednesday. Here we go. Okay. Told you. The motion problem. The motion problem. And this will also save you time next Wednesday on having more time. On having more time, because if we don't split this test into 2 parts, guys, you're basically, well, I'm not saying that you are going to run out of time, but you might run out of time. So, the motion problem that you're going to see on Monday. Technically, ideally, I would give you this entire page, but this entire page uses or has some indefinite integrals for you to solve. I think I'd rather you do the indefinite integral quiz first before I have you do that. Ooh, but you do need your calculator for this one. Ooh, struggle.
Uh-oh.
Wait, well, I kind of want to give you this whole thing. Because then you'll have way more time Wednesday for the rest of the test.
Do it.
It wouldn't just be motion.
Do it now. Get it.
You know more than.
Get it now.
Okay. Okay. Here's what part one of the test is. Okay? It's going to be one motion problem with an A, B, C, and D. I can even tell you exactly an A, B, C, and D. You might want to look at homework for an A, B, C, and D, or an example notes A, B, C, and D. It might be fairly similar. I am giving you gravity.
Yes.
I'm giving you gravity and clues, but I'm not giving you any functions, and you have to talk about or find velocities and positions. Does that make sense? So like section 4.1b, I am giving you gravity, and I'm giving you clues about something that's moving. I'll even tell you it's an up, down, not a right, left, right.
Yes.
It's an up, down, well, that's why I'm talking about gravity. Anyway, I'm giving you gravity, and you have to figure out position and velocities, okay? With clues like,
Do it.
Tell
Do
us.
it. You give me a spoilers motion on Monday.
well, you don't know exactly what you're solving for, because you can solve for different things. The words hit the ground are in there somewhere. The words hit the ground are in there somewhere. And then, of course, I mean, it is motion. So it could be like a when, it could be a how far, it could be like a how fast, right? Like all those words could be in there. Ooh, and they are. You're welcome. That's going to be the first one. It's one motion long answer. And then, okay, let me go ahead and separate. I'll separate. And then there's going to be, because this is the part you can use your calculator on, that's why we're doing this separate. This is the calculator part, and then the rest is non-calculator. So you can have your calculator for the motion, although you could just make it messy and stick it to the man. And then you can also use your calculator for an average value problem. Ooh, which means you get to do an integral in your calculator. Anyway, for the average value problem. I'm going to go ahead and rearrange it and take out the indefinite integrals to give you guys the forever quiz first so that you study, you memorize all the antiderivative formulas. We'll do the quick little like 3 integration problem, filio, like retake after the forever quiz. And then the four antiderivatives, just good old fashioned indefinite, like the integration quiz. I'll put that on the main test on Wednesday. Sound good? That way we have time to study that if we need. So the motion one and an average value in a calculator, aka do you know how to take an integral in your calculator? Do you know the average value formula? Just those 2 things. Sound good? Okay. Technically, I will also have. No, I won't. There's a bonus that has to do with the antiderivative too, and it's a fun one, and some of you might want to take time on it, so it would have been ideal for Monday, but we're just going to save all the antiderivative stuff to just join with the rest on Wednesday. And some of you will make your Wednesday feel better, because you're like, I can antiderive. Let's see. Don't forget the plus C. And then the bonus, like if you have time, you'll play with it, and if you don't, you won't, and that's fine. You have your bonus practice test, that is bonus that's guaranteed as long as you do it. Alright, so we have our practice test, check. We have our AP bulletins, check. We have all of our homework hopefully attempted and graded and put into Google Classroom.
Not yet.
But we will catch up. This weekend, what is your goal? I would say write your forever cards, start your review, and look over motion. Does that sound good? Yeah. Okay. But the nice thing is, when's our test? Wednesday. When's our forever quiz? Tuesday. So we have a little bit of time. We have a little bit of time this time. Sound good?
That's probably like.
Alright, cool kids. I have Jean's money already went to the office, right? Yeah, the tests are up here, bulletins are extra up here.
Abby.
What's up, Carl?
Monday, Tuesday, and Wednesday, like the APs.
Alright guys, I'll see you later.
Spend it together. Gov, Calc, and Lit.
Why are we talking about AP week?